So today we're going to talk about imaginary numbers. An imaginary number, they exist because mathematicians needed a way to take the square root of a negative number. If you go through the math, you will find that there is no possible way that a perfect square can be negative. So that's why they came up with imaginary numbers. So an imaginary number, we label it I. So I is defined as the square root of -1. So I is not -1, it's the square root of -1. So to simplify radicals that have imaginary numbers, here's the process. This negative right here immediately tells me that this is an imaginary number. So I will bring it out as an I, and then I just have the square root of 9. Well, the square root of 9 is 3. So this will simplify to 3i. Same thing with number 2. This negative will come out as an I, and I am left with the square root of 196. So if you simplify this down, you get 2 and 98, 2 and 49, and then 7 and 7. So if you remember simplifying radicals, we look for pairs. So I have a pair of 2's and I have a pair of 7's. So those will come out as 1, 2 and 1, 7. So I will have 2 times 7 times I, which is 14i. Number 3 here, we have the square root of -32. This negative will come out as an I, and then I simplify the square root of 32. So you can do 4 and 8. 8 is 4 times 2, and I'm going to stop here because I already have a pair of 4's. This 2 is left over, so it stays inside of the square root. So I would have 4i times the square root of 2. Number 4, I have 3 times the square root of -80. So again, this negative will come out as an I. I will have 3i times the square root of 80. I can simplify the square root of 80 down. So 8 times 10, 4 and 2, 5 and 2. Let me actually switch those around. 2 and 5, 4 goes down to 2 and 2, so again you're looking for pairs. So I have a pair of 2's here, I have a pair of 2's here, and then this 5 is left over. So this will simplify to 2 times 3i times the square root of 5. So 2 times 2 is 4, 4 times 3 is 12, so I will have 12i square root of 5. Now let's look at solving equations. So normally we have difference of squares, and I've told you in the past that it has to be subtraction in order to be factored using difference of squares. So here we have addition. Here's how you would solve this. You want to isolate the x squared. So I'm going to subtract 81 from both sides. I will get x squared is equal to -81. And then the opposite of a square is the square root. So if I take the square root of -81, that negative will come out as an I, and then I just simplify the square root of 81, which is 9. So this is equal to 9i. So that means x is equal to 9i, but anytime you take a square root, you need to add a plus or minus in front. Let's look at number 2 here. Again, we need to isolate the x squared, so I'm going to subtract 9 from both sides. I get 2x squared is equal to -8. Divide by 2 on both sides. X squared is equal to -4. Then we take the square root. The square root of -4, that negative will come out as an I. Well, I square root of 4. Square root of 4 is 2. So this would be 2i. so that means x is equal to plus or minus 2i. All right, and let's look at this last equation here. 4x squared plus 15 is equal to negative 9. Subtract 15 from both sides. You get 4x squared is equal to negative 24. Divide by 4. X squared is equal to negative 6. Take the square root. If I take the square root of negative 6, the negative comes out as an I. And if I break down 6, its factors are just 3 and 2. I don't have any pairs that can come out. So 3 and 2, they stay. 3 and 2 multiplied together, you get 6. So that means that x is equal to I square root of 6.